In this video and the upcoming video, we're going to introduce the idea of paths, curves, and a number of different formulas and features related to these objects. So a curve is just some kind of line in space that might curve around a little bit. So what I've drawn here is a curve, and a path is a certain way of traversing the curve. So it's often a parametric equation, well, it is a parametric equation, where over time you have a point that traces out the curve. So for example, at t equals 1, you might have a point right here, or sorry, at t equals 0. Then maybe at t equals 1, you're around here. And then maybe at around t equals 2, you're around here, etc., etc. So over time, you're tracing out this curve with this point. And we could talk about a few basic features here. One feature you could talk about is how fast is this point moving as it traces out this curve. There's two different ways of talking about that. We can talk about the velocity of the point. That's telling us how fast is it tracing out the curve with direction included. And that's just going to go ahead and be the derivative of your path. So that, in this case, would be -3 sine of t, 3 cosine of t, 4. So the velocity of the point tracing out this curve at time t would be given by this vector. If we want the speed, and this is going to be one of the first things that we really care about, that's just going to be the magnitude of velocity, or the magnitude of x prime. So I was interested in the speed. This would be the square root of -3 sine of t squared, all of that squared, plus 3 cosine of t squared plus 4 squared. So that would be the speed at time t. And the good news is we can actually go ahead and trace out a little bit, or we can simplify this a little bit more, because we'll notice that we have 9 sine squared of t plus 9 cosine squared of t plus 16 equals, we can use some Pythagorean identities. 9 times sine squared plus 9 times cosine squared is just 9. So 9 plus 16, and that's just going to end up being square root of 25, which equals 5. So we see that as this point is tracing out this curve, it's moving at a constant speed of 5 units per second, we could say, as a unit of time. So these are two kind of basic ideas. One more thing we might care about is how long is this curve? And there's a few different ways that you can think about the length of the curve. So when we're saying how long is it, it's basically saying if I were to take the point, let's say if we were measuring the curve, how long is the curve from t equals 0 to t equals 3 pi, we'll say. And as I said, there's a few different ways you could think about that. You could think of it as taking the point where t equals 0, taking the point maybe up here, where, actually that's probably not where it equals 3 pi. It equals 3 pi way up there. Kind of grabbing those two endpoints and then pulling the curve taut. And how long is that curve once you've pulled it straight? One way that you can think of measuring that is you can think of that as kind of integrating the speed, because speed talks about change in distance over time while ignoring direction. So if we integrate the change of distance over time ignoring direction, that should probably give us how long we actually traveled. So there's a bit of a more formal way to do that, but that's a good place to start with it. So our idea is we'll integrate speed. And so if we're interested in that, we're going to integrate speed on the interval 0 to 3 pi. We'll integrate x prime, the norm of x prime of t dt. You'll notice that we got very fortunate that t didn't end up being in our speed formula. All the t's kind of disappeared, which was wonderful. That does not always happen, but it happened in this case, which will make life nice. So when we're trying to integrate the speed from 0 to 3 pi, that's just going to end up being 0 to 3 pi. We're just integrating the constant function 5, which ends up giving us 15 pi as the distance or the length of the curve from t equals 0 to t equals 3 pi. We call this length arc length. So those are kind of three starting concepts that we can get just from the parameterization. These are different features of how the particle is moving in space. And then this last one was actually a feature of the curve itself. It's saying we have this curve, how long is it from this point to this point? So there is a brief introduction to paths and curves and some basic features.